In this video, we'll be covering how to write a time-based autonomous. So this autonomous will not be using sensors and will rely solely on time. In autonomous mode, we write code for the robot to execute without any input from the joysticks. Before you write any autonomous code, it's extremely helpful to sketch out your robot on the field and to plan out exactly what you want your robots to do. So creating an algorithm, which is just a list of steps, can greatly speed up your code. Over here we have a robot that's going to grab this ball and put it inside of that purple bucket. So to do that, we would go forward, right, so forward, and then we grab the ball, so we just grab, just close the claw, then we want to turn right, and then go forward to the bucket, and then we want to lift the arm, we want to release the ball. So then lift, and then release. And that very simple algorithm can really speed up how we write our code. Okay, so now that we have our algorithm, we are just going to list those steps into ROBOTC. So go forward, grab, turn right, move forward, lift arm, and release. To do this, we go to the autonomous section of ROBOTC using the competition template, and we just remove everything there, and we just list the steps that we want the robot to go into. And now we can just start listing code in the sections directly under each step. So keep in mind that when we were doing driver control, we set the motor equal to a power level from the controller. And in this case, since we're doing autonomous, instead of setting it to a controller, we set it directly to that numerical value between -127 and +127. So with the general structure for time, we always set the motor equal to a power level. We set the time, how long we want it to happen, and then we always stop the motors right after. So to move forward, we just make both sides of the wheel move in a forward direction, which is just positive values. And so we can just use a number such as 70, which is about moderate power. And then we set the right side, we set that equal to the same power level to make sure that they're going at the same speed and moving forward. And then next we say how long we want the robot to execute that command using the wait command, and we say 2000. As you can see, this is in milliseconds, so 1000 milliseconds makes 1 second, so this is 2 seconds over here. So the robot is going to be moving forward for 2 seconds. And a key thing to remember is always set the motor equal to 0 right after we finish the 2 seconds, or it'll continue moving forward. So just like that, we have the forward motion of the robot. Next, we want to grab the ball, or the red object. When we move up, we want to grab it. So to grab it is very simple. We just close the claw. So we say motor, claw motor, and then we just set that equal to, let's just say 90. And we do the same wait command. So maybe only 1 second for this one. And then we have to remember to always tell the motor to stop moving, so we set that equal to 0 after that 1 second mark. And so with these numbers, such as 2 seconds and 1 second, these are just testing values. So once we actually put the robot on the field to execute the program, we just modify these values to get the distances and the grips that we want from the robot. The next step here is to turn. So once we go grab, we want to turn towards the bucket. And to do that in ROBOTC, what we want to do is we want the right side to go backwards and the left side to go forwards, and this will cause the robot to turn to the right. So to do this, we have the right set to negative values. So we just say motor wheel right will be going to negative 70, and then the left side will be set to a positive value, equals just 70, so it will turn in the positive direction. And then it looks like the distance from here, well, the turning distance is probably maybe half a second, so we'll say maybe just 500. And this can change once we do start testing it. And then we have to remember to always set the values back to 0. Okay, so next we want to move forward. So we're just going to copy the same code to move forward. Okay, and when we look here, the distance from the ball to the bucket is a little bit longer than from the start point to the ball. So we just say, instead of 2 seconds, maybe it's 3.5 seconds. And this will just need to be modified as we test it. Finally, we want to lift the arm, so we just motor arm left, and then set that equal to maybe 100 if the ball is heavy, so we have more power. And then motor arm right equals 100. And then maybe you just want to lift it for 2 seconds. And then set the power to 0. Actually, in this instance, we want the arm to stay in its position before it drops. And so whenever we want the arm to stay still or locked in a certain position, we set it to a really low power level. So this low power level won't lift the arm because there's not enough power, but it'll stop it from coming down. So we can set it to about 10, and that'll keep the arm in its current position. And then the final step is to release, which is just the opposite of grabbing. So we can take this code for grab, and then we can put it in release, and then just set it to negative, and so it just releases instead of grabs. So with this code over here, this time-based code, we can fulfill this algorithm of dropping the ball into the bucket. Thank you.